Assalamualaikum and hello everyone, especially Saraja. So today we'll be presenting about experiments Coulomb's law. Before we begin, I would like to introduce my fellow teammates. First of all, we have Nurfatin Diana, and then Nuraryani binti Mohamad Nor, Nur Eva Natasya binti Mohamad Shahril, Nurizzati Damia binti Amir Hamzah, and lastly, Ainur Najieha binti Radzi. Now we can move on to our first presenter, which is Nur Eva Natasya.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Eva Natasya binti Mohd Shahril, and me and my team today are going to present about our lab report experiment 1, Coulomb's law. Our objectives is to satisfy Coulomb's law experimentally, to study the parameters that affect the electric force, and to find experimentally the electrical constant K. For our procedure part 1, the link given was clicked and the change Q1 and Q2 was fixed and the values were wrote in the table 1. The distance between the two charges was changed as shown in the table 1. The force value for each distance were recorded and table 1 was filled in by finding r squared and 1 over r squared. Part 2, the link charge Q1 and the distance V was fixed and their value were filled in the table 1. Q1 was controlled and was fixed at 5 microcoulomb while the distance was fixed between the two objects at 6 cm. Then, the results were recorded in the table 2. The charge of object 2 was changed as shown in table 2 and the electric force between the two objects were recorded in table 2.
So thank you, Eva. So next, we're going to look at the data and analysis graph for experiment 1. In the table 1, the charges at point 1 and point 2 is different, which is 1 is 2 microcoulomb while 2 is 4 microcoulomb. So the electrical force that we get in the table 1 is increased as the distance is increased. So for the table 2, we can see that Q charges at point 2 is different and the distance is constant, which is 6 cm, and the electrical force we get is decreased. Next, we're gonna look at the graph analysis, which is as you can see in the picture, this graph proves that the relationship between electrical force and distance, which is inversely proportional to each other. So next, I will pass this presentation to Fatin.
Thank you, Najieha. Assalamualaikum. My name is Nur Diana binti Zulkefli. So I will continue this presentation with the part analysis of creation in experiment 1. First of all, we plot a graph relate Fe to 1 over r squared. The graph shows that Fe is directly proportional to 1 over r squared. Next, we found the value of the electric constant K using the formula of slopes, and then we substitute into K equal to M divided by Q1, Q2. So the value of K we got is 8.99 10 power of 9 nm square per c square. Next, we calculate the percentage error using the formula percentage error equal to experimental value minus theoretical value divided by theoretical value multiplied with 100%. So the value of the percentage error we got is 1.11 10 power of negative 3%. Next, we plot a graph relate Fe to Q2. The graph shows that Fe is directly proportional to Q2. And then we calculate the value of the electric constant K by finding the value of M using slope formula, and then we substitute into M equal to KQ1 per r squared. So the value of K we got is 8.99 10 power of 9 nm square per c square. Then the value of the percentage error we got is 1.11 10 power of negative 3%. Next, I will pass to Damia to continue this presentation. Thank you.
Thank you, Fatim. Assalamualaikum. My name is Nurizzati Damia binti Amir Hamzah with the student number 2020-868468. Now I'm going to explain the discussion for experiment 1, Coulomb's law. Coulomb's law states that electric force between 2 point charges is proportional to the product of the charges and inversely proportional to the square of the distance between them. The equation below shows that electric force is equal to electric constant K and will multiply with 2 point charges Q1 and Q2 and divided by the square of the distance between the charges, r squared. This experiment was divided into 2 parts, part 1 and part 2. Both parts were conducted virtually using PhET simulation. The first part of the experiment, the result obtained showed that the distance between two charges were adjusted decreasingly and the value for electric force increases. Furthermore, a graph relates electric force and the distance between two charges were plotted, and the graph showed that electric force is inversely proportional to the distance between two charges. Next, a graph relates electric force and 1 over the distance between two charges squared were plotted, and the graph showed that the electric force is directly proportional to the 1 over distance between two charges squared. The value of electric constant K were calculated by using the slope formula m equals to y2 minus y1 over x2 minus x1. Then the value were substituted into formula K equals to m over q1 times q2. The value obtained is 8.99 times 10 to the power of 9 Newton meter squared over Coulomb squared. Next, the percentage error calculated is 1.11 times 10 to the power of negative 3%. The next part of the experiment, part 2, the result obtained were recorded in table 2. The charge Q2 were adjusted decreasingly and the value of electric force increases. The graph relates electric force and the charge Q2 were plotted. The graph shown that electric force is directly proportional to the charge Q2. The value of electric constant were also calculated by using the same slope formula m equals to y2 minus y1 and x2 minus x1. Then the value was substituted into the formula m equals to k q1 over r squared. The value calculated is 8.99 times 10 to the power of 9 Newton meter squared over Coulomb squared. Then the percentage error obtained is also 1.11 times 10 to the power of negative 3%. For both experiments, to calculate the percentage error, the formula PE, percentage error, is equal to experimental value minus exact value or theoretical value divided by exact value times 100 was used. There are a few suggestions on improvement that can be made to reduce the error percentage and get a more accurate result. First, avoiding parallax error by placing the position of the eyes vertically to the measuring scale. Next, one must wear an appropriate clothing that does not accumulate a significant amount of static charges, as it could impact the result of the experiment. That's all from me, and I'll pass this to Nuraryani.
Thank you, Damia, for the presentation of discussion. Hello, my name is Nuraryani binti Mohamad Nor, and I'm going to talk about conclusion for experiment 1. From the experiment, all the objectives are determined and is satisfy Coulomb's law. The formula for Coulomb's law is F equal to K multiplied with Q1 and Q2 per R2. For part 1, we can conclude that the square of the distance is inversely proportional to electric force, while charges of objects Q2 are directly proportional with electric force. This also can be identified by the graph that are being plotted in part 1 and part 2. They are repulsive and attraction force occur between objects that can be identified by the sign of the products. The electric constant can be identified in this experiment by the data record in table 1 and table 2. All the data record also satisfy with all the conditions and relate to what Coulomb's law state. That's all for experiment 1. Thank you for listening.